All right, now we're going to measure and construct segments. So in geometry, a rule that is accepted without proof we call a postulate or an axiom. Mostly I'm going to call it postulate. And a rule that we do prove is called a theorem. So postulate we don't prove, theorem we do prove, just like in the previous video we had undefined terms and defined terms. Postulate's undefined, theorem is defined. And the first one we're going to talk about is the ruler postulate, which tells us that the points on a line can be matched one-to-one with real numbers. The real number that corresponds to the point is the coordinate of the point. And as we know from when we were younger, learning about putting things on the coordinate plane, all points have an x and a y. And we write that as x, y. So here we have point A and point B. And point A is on x1 and B is on x2. Those are the coordinates. Now the only thing that that information is telling us is that A is in one place and B is in a separate place. That's what the x1 and x2 tell us. A is somewhere and B is somewhere else. So if we want to know the distance between the 2 points, A and B, we write it as AB. And as we recall from the previous video, this is line AB. This is segment AB. This is ray AB. And now we have AB, which is the distance between A and B. And this is going to be a number. And we find it by using the absolute value. So here we have AB, and we take the value of B minus the value of A, the absolute value. Why do we need to have the absolute value? Well, think of it like this. If the distance from your house to school is 1 mile, then the distance from school to your home is not -1 mile. No, it's still 1 mile. Distance is always a positive number. We're always going to traverse a distance. So here we're just refreshing. Segment AB and all the points in between. So this is the thing, the segment. The distance is AB. That's the distance or the number. So an actual thing or a number. And if we keep it in our head that way, we know what rules we can use with each nomenclature, what information we're getting from just either this or this. So let's use a ruler and measure these guys out. Where are we at? All right. There's our 0. And we're going to measure to the nearest 1/4 inch. 1/8 of an inch, sorry. So we got 1, 2, 3, 4, 5, 6, 7, 8. So our ruler's already an 1/8 of an inch. So here's 0. We're going to come down to 4. 1, 2, 3, 4, 5, 6. And we're measuring from the middle of the dot to the middle of the dot. And our nearest is going to be here, which is 7/8. So it's 4 and 7/8. Our next guy, we're going to go from the middle to the middle. And we're going to be 1, 2, quarter, to the middle. So right here is almost a 2.5. So we got to make a value judgment, and I'm going to call it 2.5. 2.5. I don't know why it's inches. This was also inches. So let's come down to our last one from the middle to the middle. And that's going to be, boom, right on 3.5. So if we're going to use our ruler postulate, we're going to use our ruler. We're going to measure to the nearest 1/8 of an inch. Right there. And we want to go from the center to the center, not from the outside to the outside, because we're adding a whole bunch of extra distance on. All right, let's get rid of that ruler. Congruent segments. So line segments that have the same length are called congruent segments. And an equal sign with a little squiggle on top means is congruent to. And this little dash tells me that AB is congruent to CD. Well, segment AB is congruent to segment CD. Now lengths are equal because numbers are equal. 3 equals 3. 5 equals 2 plus 3. Things are congruent. That's why we have the extra little squiggle on top of our equal signs when we're talking about congruent. Things are congruent, lengths are equal, numbers are equal. So let's figure out are JK, segment JK and LM congruent? Well, here is our JK. Here is our LM. So we need to find the distance. And I don't like red, so we're going to change the color. So JK equals the absolute value next to minus a minus 3. Well, minus a minus is a plus, so we have the absolute value of 5. And the absolute value, of course, is 5 because the absolute value just tells us how far away from 0 on the number line is it, and we're always going to have a positive number. Let's do LM. LM, which is the number, is going to equal the absolute value. Now here, the x's are the same, but the y's change. So we're going to use the y's because that's how far apart it is. -2 minus a positive 3. That's going to equal the absolute value of -5. And -5, of course, is 5 away from 5 on the number line. So 5 equals 5. So segment JK is indeed congruent to segment LM. Keeping it as simple as we can. Okay, the next idea we're going to talk about. When we have 3 points that are collinear, and we recall that means they're on the same line, we can say that one point is between the other two. So here I have A and C. Let's highlight it, A and C. So B is clearly between A and C, because if I go right straight down that line from A to C, I run into B. If I come over here between D and F, and I go from D to F in a straight line, I don't run into E. So therefore E is not between D and F. In geometry, they have to be collinear. They have to be on the same line to be considered between each other. Which is going to bring us to our next postulate, which you were all excited for, and it's our segment addition postulate. So, if point B, right here, is between A and C, then AB plus BC, AB plus BC is gonna equal AC. So the two little ones add up to the big one. The two little ones add up to the big one. So we want to find DF, which is the big distance. And we know by our segment addition postulate that DF equals DE plus EF. DE is 23. EF is 35. So DF is going to equal 23 plus 35, or 58. Two little ones add up to the big one. Well, what if we have a circumstance where we know the big one and a little one? Well, nothing changes. The big segment equals the two smaller segments, GH. And we're just going to plug in the information we know. So FH is 36, FG is 21, and we want to know what GH is, so we're going to leave that there. Then we're just going to do our handy dandy algebra. And find out that GH equals 15. Most of you already knew that, but I like to do it anyway. Let's do one more example. In fact, why don't you pause the video, solve this for yourself, and then hit play and see how you did. All right, let's see if I can get the same answer you did. So xz equals xy plus yz. xy is 14, yz is 27. We're finding xz. So xz is 14 plus 27, or 41. Take a shot at this one, find xz, then unpause, see how you did, and then answer the second part down here, and then unpause and see how you did. All right. Let's see how you did with xz. So xz equals xy plus yz. xy is 23, yz is 50. So xz equals 23 plus 50. So xz equals 73. Good job. So answer the question down below and pause the video, answer it, see how you did. Then hit play and we'll go over it together. All right. So can you use the segment addition postulate, find the distance between points y and z? No, you may not. Point Y is not, we'll highlight that, between W and Z. My red line is WZ. Y is not between the two. All right, so that's it for section 1.2. Good job, and I'll talk to you in the next video.